Hey guys, welcome back to this course. In the previous video we had explored the sets tab. Now let's move on and explore the vector tab, which contains 5 panels and 71 components. You have panels like field and grid, plane, point and vector. So we will be exploring some of the very important components under all of these panels, and you can find this particular script which is named as 3 the vector tab under your exercise files, and if you have opened it up it will look something like this. So under the first component, which is the deconstruct plane, you can find this component right here. You can use the alt and your mouse to figure it out where it is located. So I have basically used this particular component to actually deconstruct a plane. Now you need to understand what deconstruct means. Deconstruct is basically exploding or breaking down a geometry or a plane or a direction or an extrusion or a number. It can be really anything, but deconstruct basically means to break it down into parts and pieces. So over here I am taking a plane in the first place, which is the XY plane. I'll come to the XY plane first, so I'll just turn it on so that you guys can understand it first. So if I turn it on, which is basically if I select it, it turns green, and I use the central mouse click and I click on enable preview to turn it on. See, this is the XY plane of the Grasshopper window. So the XY plane of the Rhino window is this thing is the XY plane of the Rhino window, which means the ground plane, you know, the ground line that you have. And if you use the XY plane component in Grasshopper, which I'll come to later, it's already located right over here. XY, XZ and YZ planes, I'll be explaining it. It's under the vector tab only. But first of all, let's understand the deconstruct plane first, and then we'll go to the XY plane logic. So I'll just click over here. So you see you have the XY plane. So I have taken that plane and I have broken it down. So what do you get when you break down a plane? You get these many things. You get the origin point, which is basically this particular point, this point right here, as you can see the red dot. So I have basically taken a point component as the output, and I have this origin right here, this point. And you also get the x-axis, y-axis and the z-axis vectors. Now before I move into the logic of vectors, you need to understand what a vector is. A vector is basically anything that has a direction and a magnitude, and a magnitude basically means amount, magnitude means amplitude, the amount of something. So I'll just use this sketch tool right over here. Now Grasshopper really offers us a lot of interesting tools. If you click on this, you can basically sketch on the canvas. So I'll be sketching on the canvas in order to explain to you guys what a vector is. So if I have any kind of a point or a location, and if I have a direction, and if I have the amount of direction, which means I have an initial location and I have a direction, say the direction is x, and if I have the amount, say the amount is 13, so it can be 13 meters, 13 kilometers, 13 any kind of units. You don't need to understand the units, but you just need to understand that it has 13 something, which is the amount or the magnitude or the amplitude. And this is the initial starting point, and this is the direction in which x will travel at 13 meters or 13 kilometers or 13 kilometers per second or 13 any kind of unit that you might want to put after 13. So using this logic, you can understand that if I break down an axis like this, it gives me 3 kinds of vectors. It gives me the 3 axes, which is basically the x-axis, which is signified by the red line. It gives me the y-axis, which is signified by the green line, and it also has the z-axis, which is usually signified by the blue line, but it's not turned on right now. So you have the z, x and the y-axis, which you can actually understand by these panels over here. You have 1, 0, 0. So you usually have x, y and z values, and then you have x, y and z. You see the y is 1, and over here you have x, y and z, and the z is 1. So these are basically unit vectors. Unit means 1. So all these outputs are giving you the direction of this particular axis vector. So if I'm deconstructing a plane, if I'm breaking down a plane into its component parts, it's giving me the origin point, and it's giving me all the vectors associated with that plane, which is x vector, y vector and z vector, or as termed over here, x-axis, y-axis and z-axis. So I'll just turn all of these things off. Now let's take a look at xy, xz and yz planes. So whenever we use any kind of 3D modeling software, we basically model on the XY plane, which is the ground plane. Now in Grasshopper, you have something known as XZ and YZ planes. So XZ plane is basically this. I'll just turn all the three planes on one by one. So if I turn on the XY plane, you see this is the XY plane. If I turn on XZ plane, this is the XZ plane. So you have the X-axis and the Z-axis. Z-axis is shown by the green over here. And if I turn on YZ plane, it's the opposite. So it's like this. So this is the YZ plane, this is the XZ plane, and this is the XY plane. So whichever two axes you follow, a plane is formed based on those two axes. So I'm following the X and the Y axis right here. I'll just turn these two things off. I'm following the X and the Y axis right here. So I have the XY plane. If you are following the X and the Z axis right here, you have the XZ plane. And if you are following the Y and the Z axis, you have the YZ plane. Now let's move on to construct point. So if you are confused at any point, where do these components come from, where are they over here in this huge array of components, just click on your Alt button on the keyboard and click on the mouse button, and you will actually find the location of these components like this. Now let's take a look at the construct point component. We have already seen construct point in the previous chapters, where you basically input X, Y and Z coordinates. You input three numbers and you construct a point at that number. So this is what happens. You can move around that point like this. It will move in the X-axis, Y-axis and in the Z-axis. So we have already seen this. Now let's take a look at the deconstruct point. So you can construct a point, you can create a point, but what about breaking it down? So if I break the point down, it will basically give me these three numbers that I had inputted initially to construct the point. So if you use the deconstruct point component, which is located right here under vector, you'll basically get these three numbers, and I've shown these numbers using the panels. You'll basically get 3.140, 3.923 and 1.346 out of X, Y and Z like this. Now let's take a look at the closest point component. Closest point component is located right here. So in order to understand closest point component, I have also used this particular component right here, which is populate 2D. So populate 2D basically populates a particular area with random points, and the count you can control that. So I'll just turn all of these things off first so that there's no confusion. I'll also delete this sketch that I made over here. Now let's go to the closest point component. Closest point component needs an input of a group of points. So I've used the populate 2D component. You can just use Alt and click to understand where it is located. Populate 2D is located right there. As you can see, it wants a region, it wants a count of points, seed, and if you have the points you can also input them. But over here I've just inputted the count and the seed, which is I have 75 points, and the seed can just be used to vary the location of the points at random positions. And the region is by default, it takes in a rectangle which has a width of 20 and height of 10, as you can see on the screen. Now you also have the population. The population basically gives you these outputs. Now from these group of points, you can basically find the closest points, their indexes and their distances. So what I've done over here is I've inputted a random point, this point right here, and I'm calculating their distances from each of these points. So I'm calculating the distance of this point from this point from this point from this, and all the others using this particular component, and I'm getting all their distances. It also gives you the list of the closest points. If I turn this on, it also gives you the list. You see, these are the closest points that are there close to this particular point right here. You also get their indexes. These are all their indexes, which is 0 for now, and you get their distances. Now let's move on to the next component. I'll just turn all of these things off and move on to the next component, which is project point. So in order to understand this component, you'll need to understand that what projection means. So if you have used Rhino 6 fairly a good amount, you'll understand what the project command does in Rhino 6. Same thing can be done in Grasshopper. So I have a point like this, and I have inputted a geometry like this using the geometry component. You can find where the geometry component is located. It's there under parameters, under geometry. Let's go back to vector, and I have basically projected this point on my geometry. Now don't worry if your geometry looks like this, like really untidy and jagged. You can just go to this small icon over here and turn it to high quality, and now it will look much better. Now if you have this particular point you wanted to project on your sphere, you give it a direction. Now the direction basically is the vector, the projection direction. Always understand that any component you want to attach to an input, please keep your mouse arrow on that particular input and check which component is it asking for. In this case, look at the icon of direction, that's a vector icon. If you go to parameters and you see this particular component, it's the same icon which says vector. So if I keep my mouse on direction, you see you have the same icon right there. So it's asking for a vector or a direction. So I gave it the x direction because that made sense, because since my sphere was over here, it will actually ask for the x direction. I want to move this point like this, and this direction is the red axis, which is the x direction. So I've given it the x vector and I've given it this geometry, and it basically got projected like this. See, this particular point got projected right on the top of my geometry, right on the face of it. Turn all of this off. Now let's see the amplitude component. The amplitude component is basically what I was talking about before. In order to understand amplitude, you must understand vector first, which I've already explained. So vector is basically a direction. So it has a starting point and some amplitude and some direction. So amplitude is basically the amount of of any measurement that you will apply to a vector. So over here I have the unit vector, I have the x direction, the x vector, which is 1, 0, 0. Now I have attached this output to vector. I've created this particular panel just to see what this output gives me so that you guys can understand it. And I've also attached a number slider to amplitude. So this basically gets multiplied with this vector, and now I have 37 times the x vector value. So if my x vector is basically 28, so this output will be 37 times 28, which means if I do something like this right now, if I double click and type multiply, bring in the multiplication component just in case, just to explain to you guys, attach this to A, and if I copy this number slider, in order to copy something you can select that component, press Alt and copy it. So I'll just copy this and put it inside B. You see that I have the result as 37, 0, 0. Now if I attach this inside vector, you see it basically increases when I increase this. So it does not matter what vector you are attaching, if you include the amplitude of it, it basically changes according to that. So over here you see 37 did not get multiplied with 83, it's still giving me 83 because the amplitude is 83. So I'll just delete all of this and I'll attach this back to vector, and I have 83 as the vector. So I have 83 units in the x direction. That's what amplitude basically gives you. Now let's take a look at unit x, y and z vectors. So you have unit x, unit y, unit z, all these things that we were using over here. We have used unit x over here, we have used unit x over here. So these are basically directions. So x direction, y direction, z direction. So you have 1, 0, 0, which is x, y, z, 0, 1, 0, x, y, z, and 0, 0, 1, x, y, z. So you have, 1 in the x position, 1 in the y position, and y in the z position, which signifies which direction these particular components give you. You also have vector 2 point, which basically means that it will create a direction, or it will create a vector between 2 points. So I have created 2 points like this. Turn it on so that you guys can see. I've created 2 points like this one and this one, and I have created a vector between them. So this is giving me basically the proper vector or the direction from this point to this point. So if I change the location of this point like this, take a look at this panel right here, the direction will change. These are basically the coordinates of the direction. These are basically the coordinates of the other point. and it also gives you the length of this vector. So it's 19.38 right now. So if I click on this point and bring it closer to this point, you see how it decreases. It's 6 right now. So that's the logic of vector 2 point. So I'll turn these things off. So that's basically it. That's all the components that you need to understand under your vector tab. In the next topic, let's take a look at the curve tab and let's see what the curve tab has to offer to us in Grasshopper 3D.